Right, this problem. Turner's treadmill runs with a velocity of 1.2 meters per second, negative 1.2 meters per second, and speeds up at regular intervals during a half-hour workout. After 25 minutes, the treadmill has a velocity of negative 6.5 meters per second. We want to know the average acceleration this time for the treadmill during this time period. So let's write out what we know. So we know that it's got a velocity of negative 1.2 meters per second and then does stuff. So that means our initial velocity is negative 1.2 meters per second. And all that means is that it's going the opposite way. It's just going towards the negative direction. So if we've got, our little treadmill up here, okay, we've got, Turner running on the treadmill. Okay, if he's facing the positive direction, the treadmill's going to run in the negative direction. So that's why the treadmill has a negative velocity. So that's its original velocity, so it's going 1.2 meters per second that way, and speeds up until it reaches a speed of 6.5 meters per second in the negative direction. That's after 25 minutes, so that's after our time interval. And we're looking for the average acceleration. Okay. Well, we know our equation for average acceleration is our change in velocity with respect to change in time. We can expand that where we have final velocity minus initial velocity with respect to time. We can plug in what we know. Now, caution though, before I plug stuff in, I like to check my units up here. So here I've got meters per second, and then minutes for time. Well, I've got seconds to deal with up here, so I'm going to want to convert either minutes to seconds or all of these to minutes. I think one calculation is enough. I'm going to use dimensional analysis. If I know I've got 25 minutes and I know there's 60 seconds in 1 minute, my minutes cancel, and that's going to give me 1,500 seconds. So this here is the same thing as 25 minutes, it's just in the units that I want to use. I'm going to plug that in. So our final velocity, negative 6.5 meters per second, minus my initial velocity, which is negative 1.2 meters per second. Divide all that by 1,500 seconds. Well, a negative minus a negative is really just a negative plus this magnitude here. Okay, so negative 6.5 plus 1.2. Okay, it's going to give us negative 5.3 meters per second. Had a little issue there. All right, so we've got our negative 5.3 meters per second divided by our time, which is still 1,500 seconds. Okay, meters per second divided by seconds gives us meters per second squared. You can show that down here. We got meters per second divided by seconds is really divided by 1, so we got another fraction divided by a fraction. We can take our numerator fraction and multiply it by the reciprocal of our denominator. It's going to give us meters per seconds times seconds, which is just meters per second squared. We've got a negative, because we've got a negative there and a positive time. Let's figure out the magnitude. So we got 5.3 divided by 1,500. It's going to give us 0.0035 meters per second squared. We can put that in scientific notation as negative 3.5 times 10 to the negative 3 meters per second squared.